Hey everyone, welcome back to our Rust journey. In our last video, we mastered functions and control flow. Today, we are entering one of the most exciting parts of Rust, which are compound data types, and our first look at the famous ownership system. So, our today's agenda includes tuples, which holds multiple values of different types. Next, the arrays, which are the fixed size collection. Next is the slices, which are actually a views into the collection. Next would be the introduction to ownership system, followed by the memory safety concepts. This is a crucial video because we are building the foundation for understanding Rust's most unique feature, which is the ownership system that guarantees memory safety without a garbage collector. So let me now show you the example of tuples. Let me create a separate file for that. Tuples.rs. Here define a main function. Then suppose I'm defining a tuple named as person. So to define a tuple, uh, open the parenthesis and type your set of values into it. For example, Alice 30 and 5.7, 55.7. So this is a tuple named as person which are holding the values Alice 30 and 55.7. Each of these values are of different data types. So in this case, the types of these values are automatically inferred by the Rust compiler. Other than this, you can explicitly define the type of the values. For explicitly defining, add a semicolon and inside the parenthesis, type the data types which you want to correspond with the actual values of the tuple. Since the first is the string here, the type at the first position should be string. Second is very close to the integer data type, so give it a integer data type. I choose here I32. You can choose others as well, like I16 or I64. It's completely your choice. And for 55.7, give it a float data type. So I choose here F64. So this tuple is that one where we can define the types explicitly as well. Beyond this, Rust also empowers you to destructure the tuple and extract the values out of it into separate variables. For that, you have to work like this. Let, for example, name, age, height. Let me update this is equal to person. So this statement destructuring a person tuple into the three variables called as name, age, and height. Name will be mapped to the first uh, value in the person tuple. Second will map to the second one. Similarly, third variable will map to the third position value. Afterwards, you can check them by printing it, the values of name, age, and height. Let me show you by printing it. And feet, tall, and then give all the variable names, name, age, height. So on compiling it, you will this must print and all the values of name, age, and height should be filled into it. Let's uh, quickly compile it to tuples.rs, then tuples.txt. Yeah, so got it. Alice is 30 years old and 5.7 feet tall. Hence, the destructuring worked fine in this case. Other than this, if you want to ignore any value from this tupling, you can do so by imposing a underscore. For example, I want to extract only the name and height values and ignore the age. Then instead of the age, you can give the underscore. So your name will get the Alice and height will get the 5.7 value, and 30, which is actually the age, will be ignored. Similarly, you can print and check them as well. Ignoring age. So this is how destructuring works in the tuples. So there comes multiple scenarios when we want to return multiple values from a function. To do so, you must use arrays or the tuples to actually store a group of values and finally return them. So as a standard practice, you must use the tuples to return multiple values. And how you should proceed, let me show you. Define a function, calculate circle radius f64, specify the return type f64 f64. That is, we want from this function to return two values in a group, and that group is actually a tuple. Then define the function that what it will going to do. So let area. So in this function, I will return two things. First is area and another is the circumference. So 3.14 into radius into radius. Then let circumference is equal to 2.0 into 3.14 into radius. And finally, return this area and circumference in form of tuple. So as we have learned before that the function can return values in via two ways. First one is the explicit return keyword, and through the implicit way by just defining an expression without semicolon at the end of the function description. So here I'm implicitly returning the value here, implicitly returning value, and here now you can call it this function and check that let area circumference, calculate circle, and give the value of radius as 5.0. So here I am just calling the calculate circle, and whatever value it is returning, I am just destructuring that value here. Then println area circumference area circumference. So it's time to execute this. Rest C tuples.rs. What I got here. Oops. So I got the values of area and circumference now. Hence, it works fine. The tuple destructuring and the multiple values returned from the function. Let's now discuss the arrays. Let me create a new file for the same arrays.rs. So there are multiple ways through which you can define and initialize the arrays. First is that just declare a variable without any explicit type annotation and just declare your values. This is the one way. Another way is that you give a array name and along with it specify its type as well. For example, this type annotation is saying that your explicit array will store the 5 items and each one of them will be of data type I32. Give them values as well 1, 2, 3, 4, 5. And next way, when you have to initialize the entire array with same values, for example, if you want an array to look like this, 5 zeros in the array, then you can proceed like this. Let zeros is equal to 0, semicolon, and 5. So this will do that. It will declare zeros array with 5 items and it will initialize each one of them with the 0. If we specify the 1 here, your array will become, all values in your array become 1 like this. Alright. If you give the true value into it like true, every value in the new array will be holding the value as true. So this is how the initialization in arrays work. So in reality, while working with arrays, we often come across with the index out of bound errors whenever we try to access a value at an index where that index is not actually existing in that array. So to cope up with that scenarios, you can introduce an additional handling with the match expression like this. For example, I want to check whether the number like the index 2 is existing in the numbers array or not. If it is existing, then it should return the corresponding value. Otherwise, it should simply throw a message that this index is out of bounds, and hence it will avoid us from the runtime error. So go ahead like this, match numbers dot get to, and under the braces write like this, some value println value at index 2 value, otherwise give a condition as none, that is println index 2 is out of bounds. So through this way, when if your index 2 is not existing in the array, you will get this print statement. Otherwise it is existing, then you will get the corresponding value. Since our numbers array is holding 5 items, this will surely return a value. But if I actually give a index which is out of bound, like the index 10, so index 10 is not existing in that, and hence I must get an error here. Let's execute this. Rest C arrays.rs. I got an error at the here. We compile it. It got compiled now. Arrays.exe. So look here. Value at index 2 is 3, which is from the first match expression. Second is index 10 is out of bounds, which I got from the second match expression. So this is how you can introduce the safe uh, handling in your array accessing so that you do not come across with the runtime errors. So here arrays completes now. Another thing, there exists a new data structure named as slices, and Rust also supports it. Slices are just the references to contiguous sequences of elements, and they don't own any data. They just borrow a view from the original array and store them. This is our first taste of Rust borrowing concept. So let's dive into it and check it out. Slices.rs. For the slices, you have to first define an array. Let me just copy paste it. As a name, let numbers. Let me add some values additionally. 10. For defining slices, Firstly, declare a specific name for your slice and then add an ampersand operator, write the array name, and in whatever range you want the values to obtain, specify those range. So here I am saying that I want a slice from the index 0 up to the uh, an element just before the fifth index. So fifth index is this one where the value 6 is existing and zeroth index is pointing to the first position. So from 0 to uh, this 5 length slice will be get referenced via this slice one. The last index that we uh, give in this range is excluded by the Rust compiler. Similarly, you can introduce another slice. Let's slice 2 and number 5 dot dot. So what this do is that it will create a slice from the fifth index up to the end of the array. So it will print the from the 5 to at to the end of the array. Element 5 to end of array, and this one element from index 0 to 4. Alright. If you want entire arrays as your slice, then do this and the number just give the double dot and your entire array will now be saved as a slice. Entire array as slice. So this is how the slicing works in the Rust. For checking them by printing, go ahead like this. Println full array number same I want to do with the slices. So slice 1, slice 1, then slice 2, finally slice 3, since we have created 3 slices. Let's check by executing this. Rust C slices.rs slices.exe. So full array is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Slice 1, 1, 2, 3, 4, 5, and slice 2, 6, 7, 8, 9, 10. And lastly the entire array as slice. Rust also empowers you to use slices on the strings as well. For that, you can do like this from hello rush, then create slice on this message string. For that, write as ampersand message and specify your indexes. Let me create another other slice. So in this slices, the hello slice, I want to store reference the hello substring, while the rust slice will reference to this rust substring. That's why what I want to do here. Full string, then print the slices, hello and rust, hello, rust. Alright, let's execute this now. Slices.txt. So look here, the full string, this one is giving the full string hello rust, and this one is giving hello hello. The first hello is this, and the second hello is given by the slice hello. Similarly for the rest as well. So in the rest, you are given two methods for the slices using which you can read some values out of it. So, for example, if you want to find out the length of the slice at the runtime, you can proceed like this: println slice to length slice to dot len. The dot len method calculates the length of the slice to, and if you want the some of the values to read from it, from the slice actually, so slice to index one value. For example, you want to see that at the index 1 in the slice 2 what value is existing. So just use the indexing method same as that of the array slice 2, and in the brackets specify the index number. So let's check it out what whether it is working fine or not. Let me comment the existing print statements. Then execute rust c slices.rs, then slices.txt. Oops, I'm sorry. I didn't save that file. So yeah, slash to length is 5, as you can see from here as well, and slash to index 1 value is 7. Thus, this completes our slices tutorial. Next topic is the most important in the Rust context, and that is called as ownership. It is the most famous feature in the Rust. This makes Rust both safe and fast. And let me explain the core concept of this. So Rust has three rules regarding the ownership. First is that each value has its own owner. There can only be one owner at a time while the Rust program is executing. Means that any value in your Rust code base, only one owner at a time of that value will be existing. There will not be two owners or more than that existing at that instant. Third is that when the owner goes out of scope, the value is dropped. With these three rules, the ownership system in the Rust works. Let me show you through the code examples now. So let me create a new file, ownership.rs, fn name, declare a variable x, then a variable y, reference it to the variable x, and print it. X and y, x comma y. So in this case, both the values of x and y will print. Let's compile it now. Rust ownerships.rs, ownerships.exe. So value of x and y both are existing now. So in this case, what happened is that when I declared the variable y and referenced it to the variable x, the value is copied from the variable x to variable y, but variable x is not removed from the Rust memory spaces. But there exists another scenario where the similar thing when I will do, the previous variable will get removed from the Rust memory spaces. Let s1 is equal to string from hello, and let s2 is equal to s1 print ln s2 is s2. If I try to print the s1, I will get an error. Let me show you the error first so that you can get the idea more clearly. So here look that borrow of moved value s1, value borrowed here after move. That value is borrowed from the s1 into the s2, and ownership also moved from s1 to s2. Hence, S1 is not existing in the memory of the rest. It got removed from there, and it is giving the hint that if you want to keep the S1 into your memory as well, and you want it to be valid while your execution is going on, you can do so by the deep cloning of the S1 variable to S2, and for that you have to specify like this: let S2 is equal to S1 dot clone. So let's recompile it now. X1, Y, X and Y are both 5 and S2 is hello. And let's now do the cloning method, which I got hint from the Rust error logs. So in this case, both S1 and S2 will be valid. S2 is hello and S1 is hello. So keep remember that whenever you are directly referencing an existing string and directly initializing another string through the is equal to operator like this, uh, there might be chances that your ownership from the S1 string will be moved to S2. In case you want to retain both the strings, you must do the deep cloning like this. So this is how the ownership, borrowing and deep cloning works in the Rust. Let's now summarize the key takeaways from today. First is that use tuples for grouping small and related values of different types, and use array for the fixed size collections of the same type. And the third is that prefer the slices as function parameters for the flexibility, because function parameters are in most cases the viewing variables. Next is that understand the ownership system clearly. It is the Rust foundation, and Rust use it for the memory safety. Use the deep cloning via the clone method, and do so whenever you actually need both the original and the new variables to be retained. Other than this, otherwise you can use the ownership system to move the ownership from one variable to another variable. And lastly, leverage the destructuring of the tuple and the slice for the clear and readable code execution. Therefore, today we covered that tuples for the grouping different data types and arrays for storing same data type collections. Third was the slices for the creating the flexible views on the data. Next, we checked it out the ownership system fundamentals. And lastly, we checked out the moving an ownership from one variable to another versus the deep cloning into the rest. You have now been introduced to Rust's ownership system. This is the feature that makes Rust uniquely safe and fast. In our next video, we will dive deep into borrowing and references, which let us work with data without taking ownership. This is where we will learn how to write efficient Rust code that avoids unnecessary copying while maintaining safety. It is one of the most important concepts in Rust, so don't miss it out. If you have any questions about tuples, arrays, or ownership, drop them in the comments below. Like and subscribe if you are finding this series helpful, and I will see you in the next video. Thank you.